In examples 12 through 17, we are going to discuss how to use the future value of an annuity formula. Okay, so if you turn to page 9 of this note packet, right above example 12, you are told to use the formula A equals P times all of 1 plus R over M raised to the MT minus 1 all over R over M, which is the future value of an annuity formula, to solve the following problems. Okay, so let's take a look at example 12. Okay, so here we go. What is the final balance of a retirement account earning 5% interest compounded weekly if $40 is deposited at the end of every week for 35 years? And then how much of this final balance is interest? Okay, we first saw this problem back in example 5. This is example 5I. So let's go back over there and look. Okay, so here it is, example 5I. You read through it, same problem. Okay, we labeled this as a future value of an annuity problem. Okay, so again, let's talk about why. Okay, so let's go back up here. Remember when I told you you want to use this particular formula. Okay, it's a very specific situation. Okay, you need to be saving money. Okay, and you're saving money through regular deposits. Okay, and also there's no withdrawals. Okay, that is specifically when you want to use this particular formula. Okay, so remember the whole idea of these regular deposits, regular payments, that makes this an annuity. Okay, like I said, there's going to be other annuity formulas that we're going to be introduced to a little bit later, but when you are saving money through regular deposits, you want to use the future value of an annuity formula. Okay, that is exactly what is going on here. Okay, there is a retirement account, and to save for retirement, what's going on is $40 is deposited at the end of every week. Okay, so there are these regular deposits of $40 into the retirement account. Okay, so that happens for every week for 35 years. Okay, so saving money for retirement through regular deposits. So you want to use the future value of an annuity formula. Okay, all right, so let's go ahead and write this formula down. We haven't worked with it yet. Okay, it's a little bit more complicated than the compound interest formula. Okay, but the good news is that all the variables pretty much have the same meaning as they did in the compound interest formula. Okay, so let's figure out what we're looking for and the value of the variables that we do know. Okay, there's two questions here. Let's start with the first part. Okay, the first part of the question says, what is the final balance of the retirement account? Okay, so basically, if this were your retirement account and you were the one putting in the 40 bucks at the end of every week for 35 years, and so then your money's growing through those regular deposits and through the compounding of the interest. Okay, you want to know the final balance of your retirement account at the end of the 35-year period. Okay. All right, so I will put that right here. So final balance of the account. Okay. So let's see, well, we're looking for the final balance. Okay. If you remember in this formula, okay, let's get this out of the way. We know that R is the interest rate as a decimal, M's the number of compoundings per year, T is the time in years, okay? P is the amount of these regular deposits or payments, okay? And then A is your account balance, okay? So in this case, we're looking for the account balance or the final balance. So we're looking for the A value, okay? P would be the amount of each deposit, so that's going to be the $40 every week. Okay, R is the interest rate, so 5% is the same as 0.05. The interest is compounded weekly if you read it. Okay, so that means ILM is going to be 52. Okay, and then you're doing this for a 35-year period, so time is going to be 35 years. Okay, so that's what you would plug into the formula. that is going to give you the final balance of the account after the 35-year period. Okay, so let's go ahead and plug all that in. So we're going to get A equals 40 times, in parentheses, 1 plus 0.05 divided by 52 raised to the 52 times 35. Okay, then there's a minus 1 in the numerator. Okay, as soon as you finish with the exponent, then you have to go out and subtract 1. Okay, don't forget about that 1. Okay, everything is divided by r over m. Okay, so this is exactly how you would plug into it. Okay, we are going to go to the calculator and put this in to get our account balance. Okay, like I said, this is definitely more complicated than the compound interest formula. So what we're going to do, okay, don't try to put this in the calculator at one time. You'll end up making a mistake. When you put this kind of thing into the calculator, you want to start with the most complicated part first, okay? So if you look at this as a whole, you have 40 times all this stuff in brackets. So we're going to start with the stuff in the brackets, and we're going to put that in the calculator first, okay? Now, if you look within the brackets, you have the top and the bottom of this fraction, and out of the top and the bottom, what looks more complicated? Well, definitely the top, okay? So our plan is we're going to start inside the brackets, put in the numerator, okay, get that value, and then divide that result by this denominator, okay? And then that will give us the quantity inside the brackets. And then once we have that, we can multiply by the 40, okay? So that is the plan. Okay, so I'm going to go to the calculator. You can follow along as I do this, okay? When I'm working, you need to make sure that you can put this stuff into your own calculator and that you can achieve the same answer that I do, okay? All right, so let's start inside the brackets in the numerator, okay? Type it in as you see it. I'm going to open my parentheses. 1 plus 0.05 divided by 52, close parentheses, okay? Raise this quantity to a power, okay? The exponent, it's finally one we can't do in our head, okay? So make sure you put it in parentheses if you need it, if your calculator requires it to be, okay? But your exponent's going to be 52 times 35, okay? And then you need to make sure you get out of the exponent. So I'm going to go to my little arrow button here. If you can look at where my arrow is hovering, I'm going to hit that button and it's going to get me out of the exponent. And then I'm going to subtract 1. That way I can enter the entire numerator at once, okay? So this is the numerator of what is in brackets, okay? You need to take this entire result and divide by the denominator, okay? No rounding until the final answer, so you need to carry all these digits, okay? So all we're going to do is hit the division key. It's going to take that decimal and it's going to divide by the denominator, okay? You need to be careful here. The entire denominator needs to be in parentheses, okay? If you don't do it, it's going to come out wrong, okay? So open your parentheses. We're going to have 0.05 divided by 52, close parentheses. Parentheses are a must here, okay? Hit enter, okay? This number is the quantity that is inside the square brackets, okay? Now we need to take that result and multiply by 40, okay? So just hit the multiplication key. It'll take that answer and you can multiply it by 40, okay? Hit enter, and then that is going to be your stopping point here, okay? So let's go ahead and go write this down. This is going to be dollars and cents. So you're going to need to round to the nearest cent here, okay? All right, so let's see here. Go back to blue. All right, so out of the calculator came this number. All right, so let's go ahead and round. Okay, so we've got 27 cents. We look after, we have a 3, so we're going to stay the same. Okay, so the account balance of the retirement account after 35 years is $197,590.27. Okay, that's the final balance. Okay, that is a sensible answer. Okay, you know, if you're only putting in $40 a week, okay, for a 35-year period, okay, that's a pretty good amount, okay. That's typical amount you'd see in a retirement account, okay. All right, so now let's take a look. There is another part to the question, okay, so don't forget about that, okay. So not only did it ask for the final balance, okay, but if you read the very last part, it asked how much of this final balance is interest. Okay, so I'm going to go out to the side. Okay, let me put a little partition here so we don't get confused. Okay, so that's going to be the second part of our question. Okay, how much of this final balance is interest? Okay, so remember, you put in $40 every week for 35 years. Okay, your retirement account grew through these regular deposits, but also through the interest that accrued on the money that you had in the account. Okay, so we need to go figure out how much of this is interest. Okay, remember, this is not a simple interest problem. This is an annuity now. Okay, so your first thought might be, let me use I equals P times R times T. Okay, no, 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 no. We don't do that here. Okay, I equals P times R times T is a simple interest formula. Okay, not an annuity formula. Okay, so what you're going to do here, okay, you've got to rely on your common sense here, or your knowledge of money, okay? So how did I achieve this balance, okay? Interest plus what I put in, okay? So what you need to think about, what were the contributions to this account, okay? Well, $40 was put in every week. So that's 52 weeks in 1 year. So we're going to multiply by 52. That's going to give us how much money was put in 1 year. Okay. And then this was done for 35 years. Okay. So multiply by 35. Okay. So the total amount put into the retirement account is $40 a week. Okay. 52 weeks a year, 35 years total. Okay. So if we multiply these three numbers together, okay, that's going to give the total amount contributed to the account. Okay, so let's go figure that out. Let's see here. So we've got 40 times 52 times 35. Okay, so $72,800 of that was just the contribution of you or whoever into the retirement account. Okay, so let's jot that down. So that's $72,800. Okay, but this is the account balance after the 35-year period. Okay, so this number, the 72,800, that was the contributions by you or whoever. Okay, this is the account balance after 35 years. Okay, so the difference is the interest. Okay, so the total interest is going to be the account balance after 35 years minus the amount that was put in by you or whoever. Okay, so we need to subtract the two things out. Okay, so let's go ahead and do that. Okay, so we're going to have, let's see, I'll go ahead and clear this. So we're going to have $197,590.27 minus $72,800. Okay, and there you go. Look how much interest accrued, okay, over that 35-year period. Okay, this is why you always hear start saving for retirement as soon as you can, because that interest really builds up over time. Okay, so the interest here is going to be $124,790.27. Okay, all right, so that is how you do this problem. Okay. All right, let's try example 13.